So to get your VA, vertical asymptote, we set the bottom equal to 0. So x minus 4 equals 0. So x would equal 4 and negative 4. Just remembering we have to set both those things equal to 0.
Okay.
So then when we graph this thing, so 1, 2, 3, 4, dotted line. 1, 2, 3, 4, dotted line. Do you remember how horizontal asymptote works? So horizontal, I think of it like this. If I have, let's say I have 2x squared over 3x squared, so the degree is the same top and bottom, then it's y equals, you make a fraction out of those coefficients, so y equals 2/3. If it's smaller on top than it is on bottom, so squared and cubed, then it's y equals 0. And then if it's bigger on top than it is on bottom, then it's no horizontal asymptote. So in this case, degree same top and bottom, so the horizontal asymptote's at y equals 2. So you make a dotted line where y equals 2. And then almost always, when they're like this, it's a parabola, upside down or right side up in the middle, and then it goes like this, or it goes from the bottom like that. Okay? So we can always get the y-intercept. Like this one problem is just insane. But it'll help you with a lot of the different graphing stuff, even going over this single problem. So to get the y-intercept, we plug in 0 for x. So I'm going to write down here y-intercept, not in dotted line, so y-intercept, plug in 0 for x. So we get 2 times 0 minus 18 over 0 minus 16. So we get...
Could you also put it into like this one?
You could.
Okay.
Yep. So we get 18 over 16 because the negatives cancel, right? So it's 1 and change. So that means the y-intercept's going to be somewhere about there,
Okay.
right? And then you know, because the y-intercept's right there, that this part has to go down like this. Okay. And then always when it's upside down like that, it's got to go like this.
Okay.
But did she...
I think it's on the other packet.
Oh, because there's a second page of that. What is this?
Oh, here.
So I just want to see if she plugged in other order pairs. She didn't. So see how she has these points at 4 and negative 4? So that's because, or 3 and negative 3, because if we put in, to get the x-intercept, you set the numerator equal to 0. So x-intercept, numerator equal to 0. So this graph is a little different. It's unfortunate. Erase that part too. So we've got 3 and negative 3 as well. Go back. Come on, eraser. Go back. Go back. All right. Erase that and that. And we've got negative 3 and positive 3. So it's like fat at the top, right? And then she's just assuming that it goes like this because she didn't do any other ordered pairs.
Okay.
So you're just relying on that's how it's going to work out, right? like if I did that problem, I would definitely plug in 5 to prove that it's up here,
Okay.
and I plug in -5 to prove it's right there.
Okay.
But she didn't do that, so that means you don't have to do that either. All right, so this one, 24. We got x squared plus 8x plus 12. How is your factoring?
It's getting better.
Okay. So, like, I'm not going to go over that if you don't need me to go over that, right? So it's 6 and 2, x plus 6, x plus 2, over x plus 12. So if we think, oh, I read it wrong, over x plus 2, my bad. I was like, wait a minute. So the x plus 2's cancel, which means it's just a graph of a line then. And we have a hole where x equals -2, right?
Okay.
And then I also have to take that -2 and plug it back into the function after canceling. So I plug it into -2 plus 6, which would equal 4. So my hole's at -2 comma 4. So -2 on x, 1, 2, 3, 4. I'm going to have a hole right there. And then I'm going to graph this line, x plus 6. So we start at +6 on the y-axis. And I go up 1, right 1. I also go down 1, left 1. I'm skipping the hole. So my graph goes like that, up to the hole and straight through the hole. Okay? All right. Is there more on this? Of course. Like this, simplify. It's just in the wrong order, right?
Can we
Take a
do
negative
one of
1 out.
one of these ones?
Yep. So pull that sucker up if you don't mind. So possible, a spinner will land on the uppercase letter. So what is so spinner, you're just counting around how many little slots there are, right? So 1, 2, 3, 4, 5, and 5 little ones, so 10 total.
Okay.
So they're 5 lowercase plus 7 over. So what is, if all possible results are equally likely, what's the probability that a spin of the spinner will end in an uppercase letter and a consonant? So there are uppercase, there are 5 of them. And then consonants, right? Everything except a vowel, there's 7 of those.
Okay.
So, and then it's minus uppercase letter or a consonant. So you have to subtract the 3 out of 10
Okay.
because there are consonants and uppercase letters,
Okay.
right? So that's why we're subtracting from the consonants. So, because it has to be uppercase, right? So that's why you got to do all 3. So 12 minus 3 is 9, and then it's always a percent, right? So you can tell. 13, so bag contains ribbons, 8, 7, so they're 15 total. So this is without replacement, so you take a ribbon out and you don't put it back in the bag. So she selects a ribbon. Maybe what is the probability that she selects a black ribbon? So there are 8 blacks, so that's 8 out of the total of 15, right? And then she selects a black ribbon, and then she selects a green. So there's only 14 left, so that's why it's 7 over 14. And you always multiply probabilities when you're making 2 random selections, right? So this cancels to 1/2, right? And then the 8 and the 2 can cancel as well. That's why there's a 4 on top. But she'll let you use calculator for that, right?
Sure.
Yeah. So I would just multiply. Do you know how to multiply these fractions in your calculator?
Yeah.
Yeah. And reduce, math enter, enter?
Yes.
Yeah, good. Okay. So good on this one?
Yeah.
Okay. So, oh, isn't that a fun large number? Like, I would hope she would, but it's Voss, she probably would. Like, because you have to add all those numbers up, right?
Yeah.
So we're adding these two totals up
Yeah.
to get this. So, what is this? This is 8 million, and this one is 66 million. So that's adding, because that's 75. All right, so table shows distribution of labor force. Find the probability given that they are female. So female is that they work in the industry field. So female in industry, express your answer as a decimal. So females right there in industry is the 8 million up top, right? And then this 66 is 57. So all as a percent of all the females. So this is industry females, and this is total females.
Okay.
So that's how she came up with those two numbers. All right, so probability there. And here, independent events. So we're just multiplying these probabilities, right? You always multiply probabilities, so you get 4 over 52, which reduces to 1 over. And then they're both independent. Are A and B independent? Probability A, probability B, probability of A and B. Are A and B both independent? You said no, and they are both independent. That's contradictory. What does she say
I
right there?
couldn't read it.
Okay. So no, if probability of A and B is 1 over 13, it's not 1 over 15. Oh, because it's just saying right here that both of them together would be 1 over 15, and what you got was 1 over 13, so that's why they're not. Okay? I know, a little chicken scratch handwriting, right? So find experimental theoretical probability of getting heads. So theoretical is 50-50, right? Heads or tails. And then in this case, we got way more heads than tails. So 69 over 50, which is over 150. So this is the total on the bottom. So 69 heads. And this is the total. It's 150 right there. Total.
Okay.
Right, so I think of it like part to whole. Parts on top, holes on bottom.
Okay.
All right, so for it's easier to read on here. For 2 weeks, Mark recorded the color of the traffic light at the intersection. The results were red, 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 green, red, red, yellow. Make a table, so 8 reds, 1 green, 1 yellow. Oh, that's easy. Do you want to look through and see which other ones are messing with you?
Yeah.
Like, I think it's good to realize, like, the part to whole stuff and figure it out. You always multiply probabilities. Just read. I'll read them too over here. Oh, this mess with your head like that.
Yeah, I think. I
13
kind
over
of remember
23.
doing 20, but not totally.
So, participants in a study of a new medication. New medication receive either medication A or placebo. Make a tree diagram of the results. So 80%, so the first tree is the first thing, right? So 80 got the actual medication, 20% got placebo. So first thing you got to remember is to make it into decimals, right?
Okay.
And then from A, of those who received the medication, so you're just subtracting from 100, right? You get 70.76 and 0.24, right? Because it says 76% showed improvement. So you just write improvement or no improvement. And then with the placebo, 62% showed no improvement. That means 0.38's left. So I just do 100 minus 62 to get the 38, right? And then they want to know of those who received the placebo, make a tree diagram to find placebo and improvement. So that's why we're multiplying the 0.2, because 0.2 times the 0.38, so only 7% of the people got the placebo and showed improvement.
Okay.
Which makes sense, because that would be a weird thing, right? To get a fake pill and be like, oh, I feel great.
Yeah.
But the mental side of health is totally real. Okay, so, okay?
Yeah.
Yeah, good.
No,
It's just hard not to get overwhelmed.
I know. Because I started to do one of these and I just couldn't do it.
These things, because you got to multiply by the common denominator to cancel out the,
Yeah.
because we're adding, right, and equals. You could do that one if you want.
Yeah, that's
So a over, so this is plus 6 minus 6, the bottom.
okay.
So we have a over a plus 6, a minus 6. And then it's plus 2 over a minus 6 equals 1 over a plus 6. So basically what we do is we multiply all the numerators by the common denominator, which is a minus 6, a plus 6.
I can remember doing this. Okay.
A plus 6, a minus 6. And if any point, like, you're like, I'm good, then we'll just stop that problem. Like, it's totally fine. A minus 6. So
Wait,
what
why
I...
do you do the first one? Because it has...
Because
both
we're...
denominators.
The whole thing is we're trying to cancel out the denominators, right?
Oh, okay.
So that cancels out that denominator.
Oh, I see.
The a minus 6 cancels. The a plus 6 cancels. So all I have left from this entire first fraction is that a,
Gotcha.
right? So I get a plus, and then I distribute this 2 into the parenthesis. So I get 2a plus 12, and then equals, so all I have to do is multiply 1 times a minus 6, so it just equals a minus 6. And then it's way easier to solve it, right? Because you don't have any fractions. So we get 3a plus 12 equals a minus 6. And then I'd subtract a and subtract 12. And I get 2a equals negative 18. Divide by 2, divide by 2. A equals negative 9. Done.
Okay.
Now remember, when you do these things, so what's the most annoying thing is you got to make sure this answer doesn't cause any of the bottoms to be 0,
Okay.
because then it's extraneous. It doesn't work.
Okay.
Thank God you got this on Wednesday, so you get some processing time.
Yeah.
Okie dokie, so 15. Oh yeah, this was a different one anyways.
Yeah. I think that's probably
That's
good.
Let me just, you look at another one and I'll look at this and
Okay.
just ask you about a problem if I see a weird one where I'm like, oh. Like this one. So you realize when you factor it's 4-2 number. It's just like regular factoring except it's squared at the beginning.
Gotcha.
Is that good?
Yeah.
And then nothing cancels, so can't be that. You just set the bottoms equal to 0. That's where those two came up. Good.
Yeah.
So they're asking you vertical asymptote and hole. So you have a hole and then you got to plug it in. So you cross those two out,
Gotcha.
plug in positive 2 right here and right here.
Okay.
And then the vertical asymptotes is the bottom set equal to 0, excluding what cancels. VA excludes what cancels. I wrote that down. In whole, you plug it back into what, like after canceling.
Okay.
Okay. All right. Okay. Good. That's good. You get this one right? Just copy dot flip.
Yep.
Okay. Good. Let's make sure.
And then it changes into multiplication, not
Yes.
addition, right? Okay.
That's a dot of
'Cause
copy dot flip.
Okay.
Yeah.
That's what I thought, but I was doing a test and I was like, what if
I
I'm
know, you're
remembering
like,
it wrong?
oh God. Get that panic moment.
Yeah.
Super fun. Not. So you're good with factors, so that should be good.
Oh.
This one you're good, right? This one's like straightforward, right? Because VA is the bottom, so it can't be -7, and that just moves the whole thing up 3,
Gotcha. Okay.
right? I'm gonna write the formula down that goes with this, so you remember. X minus H plus K. Do you remember seeing this formula?
Oh, yeah.
Okay, good. So this one is for VA. And this one is for horizontal asymptote. And you can just see stuff on there that you can do as well.
Can we do one of the division ones?
Yep.
'Cause I get synthetic division, I just don't get this. Can we
Is
do, that one?
she gonna give you one where you have to do? She's gonna give you some where it's by hand, right? It's not all multiple choice.
No. She said, if I can remember right, she said that if it's multiple choice in the review guide, it'll be multiple choice on the test.
Okay.
And vice versa.
Okay. So she's gonna make you do one of these for sure.
Yeah.
Super fun. Okay, so I have what I think is an easier way to teach these than how she does it. Because kids always struggle with this stuff. So first you got to write it in order, right? And if you're missing, like we're missing x squared, that's why you have to put 0x squared in. So we write x cubed plus 0x squared. This will help you to listen to this one too. Plus 5x minus 8. So this is how I think about it. So I have 2 things out here, so I always start 2 over. So my first part goes right there. And I'm saying, what can I multiply up here times this to get that? So if I always like to write it on side. So what times this x, so I mean this x is this x, equals x cubed. So what goes in the blank spot?
X squared.
X squared. And it always lines up, right? So all the way down the line, it's going to be x squared. It's going that way. It's going to be x is going this way and numbers going that way. Okay? So if stuff gets out of whack, then that's your visual clue to know that something's wrong. So when we multiply these, we go x times x is x cubed right here. And then we go x times -2 is -2x squared right there. So we go x times x squared is x cubed. And then we go x squared times -2 is -2x squared. So I always put that in parentheses, the minus in front. And then I always, instead of subtracting, because I find you guys screw up subtracting, I make it addition. So basically I'm distributing this negative into the parenthesis, and I just call it the 3 switches.
Okay.
So I switch and I'm good. So then this always cancels. And then 2 minus 0, or 0 plus 2 is 2x squared. And I have to bring that 5x down. Okay, so plus 5x. So over here I say what times x equals 2x squared. That's a beautiful square. So right here would be 2x, right? And then I write it above the other x. So it makes complete sense, right? So plus 2x. And again, I'm multiplying this one times this one, and I get that number. And then I multiply this times that, and that number goes right here.
Okay.
So we go 2x times x is 2x squared. And then 2x times -2x is minus 4x. I forgot the x on the 5 there. Right? And then I make my 3 switches. Switch, switch, switch. So 5 plus 4 is 9. So we get 9x here, and that always cancels. And I bring down my minus 8. Over here I say what times x equals 9x. So what goes in the blank? 9. So plus 9. And then we go 9 times x. We get 9x right there. And then we go 9 times negative 2, you get negative 18 right there. So this one has a remainder. So 9 times x, 9x, 9 times negative 2, negative 18. 3 switches again. Switch, switch, switch. So 18 minus 8. Like that way, I just think whatever the signs tell me to do. I can think negative 18 plus 18 or negative 8 plus 18, but that's weird, right?
Yeah.
18 minus 8 is a hell of a lot easier to think about. So we get 10. So my remainder, this is a positive number, so I write plus 10 over x minus 2. So that x minus 2 comes from right there,
Okay.
whatever I'm dividing by. Okay?
Yeah.
So you can go back and listen to that. Like it's overwhelming
Yeah.
to get that whole process, but if you go listen to it once or twice,
Okay.
you'll totally get it.
Perfect.
All right.
And then,
Do you have one? Wait, let me see this one real quick. So you remember this nasty little formula?
kinda.
Because this is mean. Because this is the difference of two cubes. Let me just show you this one real quick. I'm going to make it x instead of c because it annoys me if it's not. So the formula for this, is 512. So first thing you got to do is cube root of 512. You remember how to get cube root on here?
Yeah.
So math, cube roots, 512, they get 8, okay? And you're assuming that there's gonna be a cube root. So some kids will add 512 over to the other side and cube root it. That's not remotely close to correct,
Okay.
okay? So this thing, the formula is this, a cubed minus b cubed equals a minus b, a squared plus ab plus b squared. The issue with this, yeah, it's nasty, right? The issue with this is you always have to do quadratic formula with that parenthesis. It never factors, which is annoying as hell. So we think about this by doing cube root of x cubed, cube root of 512. So cube root of, so I'm just gonna match it up with the letters like the same format. So it's x minus 8. Okay? Then I go from a to a squared, so I go from x to x squared right here. So first thing in the parentheses is x squared. Then notice that it's a plus ab, so it has to be plus right here. Even though when I multiply those, I get negative 8x, it's actually positive 8x. Have a seat. We started a little late, so we can just powwow on all this stuff together.
Yeah, I'm just gonna use the bathroom really fast.
Yeah.
Yeah. Oh my gosh. How's it going?
Great.
Yeah.
It's completely hellish, is what you meant to say. Sufferfest. Freaking insane in remembering. So this is plus 8x, which it does not seem like it should be plus 8x, but it is. Because this sign in the formula always wins. Even though it's negative, it's got to be positive. Then I square 8, and I get 64. That one doesn't matter, because if I do negative 8 times negative 8, I get 64, or 8 times 8 is also 64. You want to come?
Sure. Thank you.
All right, so here's the annoying part about doing quadratic formula. I write it different than every other teacher I've seen because I'm special. And I'll show you why I write it like that in a minute. So I'm just going to plug this in. So A equals 1, B equals 8, C equals 64. So we get negative 8 over 2 times 1 is 2, plus or minus. I'm going to square 8, 64, minus 4, times 1 times 64. 4 times 64, 256. So then we got to go 64 minus 256. So this is negative 4 plus or minus 64 minus 256. So we get, oh, that's just mean, negative 192. So if we do 192 divided by x, I think it's either 36 maybe. And then we look at the factors, 64. So this is over 2. So I divided that fraction. That's why I like writing the 2a below both, because you can always simplify both, well, not always, but many times you can simplify both fractions. So if we take square root of 192, we can break that into square root of 64, square root of negative 1, square root of 3, square root of 64 is 8, square root of negative 1 is I. That's why it's evil, right? Because you always end up with an imaginary number there, and you're just like, I want to shoot somebody right now. So you get negative 4 plus or minus 8I root 3 over 2, and the 8 and the 2 cancel to 4. So it's negative 4 plus or minus 4I root 3, and then, because that canceled, there's no denominator. So remember the thing, we look at the original, it's to the third power. So we need 3 answers. That's only 2 answers. My third answer is by setting that parenthesis equal to 0. So x equals 8. So your 3 answers are x equals 8 and negative 4 plus 4i root 3 and negative 4 minus 4i root 3.
Okay.
And what that means, like, from a graphical standpoint, it would cross at 8. So it's a positive cubic, which means it finishes up. Nope, not like that. It's like that. So that means, that's a weird one. So to go through 8 over here, and that bump wouldn't hit the x-axis. That's why those are imaginary.
Gotcha.
So anytime it's a real number, it'll cross the x-axis. Imaginary answer, it'll be above or below the x-axis, depending how that thing starts, right? Because it could also be like that. So this is negative x cubed. That's positive x cubed. So I'm recording this. I'm just going to let the recording go through both you guys since you're doing the same thing. And you can stay as long as you can handle it or want to, right? And then you'll have the whole recording anyways.
Okay.
So once your brain gets cooked, it's pointless, right?
Yeah.
So you just stay as long as you can hang in there and then just say screw it and you can listen to the video later.
Okay.
Okay?
Stay on.
She's sick too. You
Oh,
can
yeah,
tell,
me too.
right?
Me too. I actually.
You too?
I just had. Well, I woke up. I studied for chemistry for 4 hours.
Oh.
Then I went to a job interview, and
How'd
at
it
that
go?
job interview, really good.
Good.
It was at Menchie's.
Nice.
At that job interview, though, I was holding in like the crunchiest cough the entire time.
Oh, God.
So I left and like was like,
It's right on the edge. You're
Oh,
like
yeah,
you're
I
about
was,
to
like,
cough.
dying.
And, yeah.
But,
That's
yeah.
the worst.
it's all right.
All right. Do you want to get your packets
Yeah.
out and then you guys can find next question you want?
Oh God.
Then I can just, I might just watch the video.
Okay. You already cooked?
Yeah.
Yeah. Go home,
video.
take a nap, because this sickness, I'm on like day 8 right now, and I'm still feeling it.
I've
I
been-
go
yeah.
walk my dogs, and I'm
I've
like
been sick
tired.
for a week, and like we had marching band yesterday, and I
For
was
how
like,
long?
From 9 to 2,
Okay.
and I was like,
Only 5 hours.
I was cooked afterwards though.
I bet.
Would you mind passing me my charger?
Yes.
Thank you.
Did you feel better?
I feel like fine. That's the thing.
Yeah.
I was never like sick. I think it's allergies, kind of at this point,
Yeah.
plus a remainder of
It's not.
everything. Yeah.
I'm sorry, it's not. But I have allergies too. It's you got to get generic
This
Sudafed.
is so cute.
Mucinex.
God damn. Yeah, we're all struggling so hard. It's okay. We got 4 more days and then we're like
4 more
done
days.
forever.
Well, no, then we're seniors then.
Yeah, so it's basically.
Yeah.
Then you get to start senioritis in August, right?
Yay! I already have senioritis.
Yes. Junioritis.
I know.
Oh my God.
It's worse.
Junioritis is real.
I know, because you got over a year left, and you're like,
Yeah.
oh God, what if I feel it already?
Well, thank you so much.
You're welcome.
Love Ruby.
Thanks. What's your first language?
History.
Oh, okay. So
It's not too bad.
yeah.
Is it regular or advanced?
Regular.
Okay, good.
Bad.
Good.
I just need to go home and write an essay.
Yay!
Have fun.
Enjoy. Take a nap first.
I'll try.
Yep. Sometimes it's hard. Like some people sleep when they're stressed. I don't get that. It wakes me up when I'm
I've done
stressed.
nothing. I've not slept, but it's okay. It's okay. Okay, so we did that one. My math folder is like kind of crazy right now,
It's understandable.
but
This is annoying. She didn't count the test review, the 34 question test review, and you're doing this again, you know?
yeah, it's just like it's just a lot.
It's 147 problems I had to do
And
that.
like, oh, I have to find it. There was unit 5 and 6 and 7 and 8. They were giving us like one day. They were due like basically the next day. And so I couldn't like get it done. So I just used the key
Yep.
because I was like,
That's
there's,
exactly what Alexis said.
yeah,
It was too much. I
there's
couldn't do it
no
all.
way. Yeah, I was just like, there's absolutely no way that I'm gonna be able to finish all of this in time. So I
Now you're
didn't.
freaking out because you're not sure where they are.
Well, they're here.
They're
Maybe.
there somewhere. No, they're there. We will believe. So let's see what you
Well,
got
2
here.
of them are
just
there.
So this is 9 and 10. So you're
And
looking
then-
for 6, 7, 8.
Yeah. I've just had everything out like all over the place because I've been trying to review.
Yeah.
So then I had to like get all my that's just blank paper. All my old stuff out for like the
To figure out.
yeah.
Yeah.
That's what I'm doing for chemistry right now. Like my entire dinner table is just covered in all of my because I have that tomorrow and it's
Yep.
cumulative and I'm just like what's happening?
It's got to be deep in there.
Yeah. Sorry.
All good.
But I don't even really know where to start. Oh, okay. Here's one. Oh, wait, is that it?
No,
No, that's
that's
extra
not.
credit. Oh, never mind. Where is it?
You can also, but you need to turn it in.
Yeah. And I already had to print out the whole thing once.
Yep.
So that would kind of suck.
That would kind of suck.
Good God.
You could also just email me the blank ones, and then I can put it on here, and I'll send you that file.
Yeah. Let's see.
It's not looking good that they'd be this deep, right?
Yeah. Oh, there we go.
Oh my God, amazing.
Here's one of them.
Just when I gave up, that's
Yep.
when you can find it.
And I take that one. Okay.
All right, sweet.
Yep.
So these are the ones you did rapid fire. Here,
Yeah.
let's stick that one.
And I also had to print them out so I could like barely see any of it. Just printed out so badly. I don't know why.
Can you email the blank ones to me?
Yeah.
Like, can you do it now? Do you
Oh,
have
yeah.
your computer?
No, but I can probably do it on my phone.
Okay, yeah. Because then we'll have clear ones on here. We'll be able to read better.
Yeah.
I'm hoping. And this is 5. I can't believe she did 7 chapters in one semester.
I know.
Some might argue that's too much.
All of her students, they argue.
All normal humans?
Yeah.
5, 6, 7, 8. That's all you got to do. Because
Yeah, 9 and 10 I actually did, and I like understood them, I think. But,
good. Which one?
Those-
10's the probability, right?
yeah, actually,
Okay.
I don't know if I fully understood 10, but I did
You
understand
did
9.
some probability
Oh, okay.
earlier on here, but I was just talking about the problem, so you'll have
Yeah.
to like have it in front of you as you look at it.
Yeah.
And my next one's not till 4, so if we need
Okay.
to you know, we're not starting on time. We can start whenever we start, kind of
Yeah.
thing. It's totally fine.
I don't know if I don't know if I'm gonna be able to stay much past 3 though, because I still
Oh.
have like a lot of chemistry to do.
I hear you. That takes precedence, right? Because you got to get that done.
Well, yeah, because that's tomorrow morning.
Yeah, for sure.
First final.
Yikes!
Yeah.
Not an easy first final.
No.
At least you don't have chem and math in the same day.
Yeah, I just have that in A-push, which will honestly be fine because I don't really have like an A-push final. And we're meeting tomorrow, right?
Yeah,
So then, yeah.
it's all good. Plus, you'll get some off that video as well.
Yeah. Oh my gosh, this is so annoying.
Yeah, it's irritating. 80027. I'll get it autofilled. Agree. Now they have your whole life.
Yeah.
See, you guys are like, whatever. That's when my parents freak out. They're like, oh my god, they're gonna steal my identity. I'm like,
Yeah.
shut up. They're not. Five, yeah. David Dot Evans. You airdrop it. That's faster.
Oh, okay. Is it iPad 9?
Yep. Accept. Good. Next one.
I'll airdrop it again.
Got it.
Cool.
Share. Open. Okay, so you can peek through those and let me know which one you want to do. Okay.
I don't know. Maybe the roots, like 9.
Okay, 9 on module 5.
Five.
Okay. Module 5 review, number 9. That's not much better. I need to tell her about this different scanner, which scans things clearly. Let's make it smaller. So we have 2x to the 4th minus 5x cubed plus 10 equals 0. This is that thing, I saw it in here. It was on the Descartes rule of signs.
Oh.
I have this thing called, put it in there, tricky. So it's this whole lovely thing, right? So
Oh my god.
remember, this is the first time I ever saw this, so anytime I see something new, I try to like break it down so I
Yeah.
can get it too. So real coefficient, so coefficient would be 1 right there, right? So the number of positive roots is equal to the number of variation in sign or less than an even number. So x to the 5th could have 5, 3, 1. So this is x to the 4th, right? Or is it number 9 right there? So x to the 4th minus 5x cubed plus 10. So, and then I don't think we have to put in placeholders. And then remember you have to plug in negative x and then see what happens with that too. And then you make this table.
I'm gonna write Descartes' rule of signs, so I know to study that one.
Descartes' rule of signs, because this one problem could take us, and you have that, it's a
Yeah.
thing you printed from me.
Yeah.
That was probably a better explanation.
Yeah.
So this is going to be same thing, right? So it's because it goes positive, negative, positive,
Yeah.
positive, negative, positive. So it could be 2 or 0 because they're 2 sign changes. Because it goes from plus to minus and then minus to plus.
Okay.
So that's why it's 2 or 0.
Yeah.
And then when you plug in negative, right? So we plug in negative to the 4th is going to be positive. That's why that's plus. Negative x cubed would be negative, and then times negative is positive. So, and then you just keep going through plugging in the negatives, right?
Yeah.
So it goes plus, plus. There shouldn't be 3 pluses, so. Let me look at
The key.
I don't have the key, but
That's
whatever.
okay.
So it's
Okay.
2 or 0, so 4 complex roots, so 0 or 2.
Yeah.
And so complex is like the imaginary ones, real is the non-imaginary ones, right? So 4 reals.
Okay.
It just goes plus, plus, plus
Okay.
when you plug in the negatives, because that would be positive and that would be positive. So 2 or 0 negatives. So 0 or 2 for the negative roots, that's the complex ones, and then 4 for the positive.
Okay.
So if it's 0, it's got to be 4, and if it's 2, it's got to be 2,
Okay.
right? So
Yeah.
that's why. Oh god, this
This one I was confused on.
so it's
This one what is the rational root theorem?
so
That's
which
like right here.
for
number 8.
this up here.
I didn't actually do it. I just wrote down.
So I would let me look at that one. So this is module 5, right?
Yeah.
It's too hard to see on that thing. So what number are we talking about? Number
5.
8?
Or sorry, 8.
All right, so how many roots could there be? Use the rational root theorem to all possible rational roots of the equation. Do not find the actual roots. So this is that P over Q thing. Do you remember talking about that? So you do factors of 4. So factors of 4 are 1 and 4, or 2 and 2. And then you do factors of the leading, the one with the highest exponent. So the P is the end one. So these are all the P. The Q part is going to be, let's do this Q like that, is going to be 1. So we put all these different things over 1, right?
you
And
see
we
which
also
one
do
works?
plus or minus of every single one of those.
Okay.
So it could be 1 over 1. That's why there's 1 and negative 1.
Okay. Oh, because it's plus
Right.
or minus, yeah.
And then it could be positive 4 or negative 4. That's why there's plus or minus 4. It could be plus or minus 2, right? And they're all over 1. It's harder when this is like a 2 here, because then you have to divide all these, and sometimes they repeat. But so it's the end factors over the beginning factors to do the rational root theorem.
Okay.
Okay? So that's all that is.
Okay.
And nothing got eliminated, right? Because I'd have 1 over 1, I'd have negative 1 over 1, which equals 1 comma negative 1, right? Then I'd have 2 over 1, and I'd have negative 2 over 1. So that's comma 2 comma negative 2. And then I'd have 4 over 1, and I'd have negative 4 over 1. which is 4 comma negative 4. So that's why it's all those. And they just wrote at least to greatest, right?
Okay.
Like you should with domain and range.
Yeah.
No repeats. Okay, so that's rational root.
Okay.
Did you get 7 with the multiplicity?
Yeah. Yes, I did actually.
Just exponent, right?
I
For
understood that,
multiplicity, good. And then you're good on synthetic division,
yeah.
right? Good, good. Oh, this one.
Yeah.
That one is mean. So the formula for this is a cubed plus b cubed equals a plus b. Let me move that over. Run out of room. And then this is a squared minus ab plus b squared. You pray to God if she's going to give you plus, because there's another formula if it's difference. So this one I'll explain. It's a good one to listen to again
Yeah.
on the video because it's
And then I
mean.
can just read.
Yeah,
But I just want to make sure I have some notes.
for sure. Okay, so I'm actually going to move this again so I have more space. So I'm going to write the 125 and 343. It's good that this is calculator one
Yeah.
because you have to cube root both those numbers.
Yeah.
So if you cube root 125x cubed,
It's 5, right?
yep, 5x, and you cube root 343, it's 7. Good. So we get 5x plus 7. And then I go from a, here I go from a to a squared. So I have to square both the 5 and the x.
Oh.
So 5 squared is 25x squared, exactly. So in the parentheses, we get 25x squared. Then this sign in the formula always wins. So even though when I multiply 5 times 7, I get positive 35, it's still negative 35. This is a bitch because when you do quadratic formula, the numbers are gigantic.
Yeah.
That's why it's mean to give such big numbers right there, but whatever. So plus 49 because we square 7. So when we plug in for quadratic, a is 25, b is negative 35, and c is 49. So I'm going to write quadratic over here. So x equals, I write quadratic different than any other teacher because it's smarter. B squared minus 4ac. The reason I write 2a on both sides is because so many times you can cancel this fraction and that fraction. And when you guys write it with the one big 2a, you'll cancel one fraction and then forget to cancel the other one.
Okay.
So that's why I write it separated out. And you can do that. It's no big deal. So it's minus 35 or 35. 2 times a is 2 times 25, which is 50. So 35 over 50, I can divide 5 into top and bottom, becomes 7 over 10. So I'm reducing already, right? So I can just not mess with it. Then we have plus or minus. Square root of 35 is a number I don't know. Second quit, 35 squared is 12, yeah. Who would know that, right? 1,225 minus 4 times 25. That's a times c, which is 49. So I'm going to do negative 4 times 25 times 49. And I get negative 4,090. So this is all over 50. So 7 over 10 plus or minus. So I'm going to do 1,225 minus 4,900, which is negative 3,675. So I'm going to put 3,675 divided by x here, so I can find the biggest one I can square root. I want to see if I can square root 1225. So I can square root 1,225. Right, because I just squared that to get that in the first place. So this is still over 50. So I'm going to write over to the side and break apart the square root. And this, you have to do this, which is crappy, but true. So square root 1225. Square root -1, because that's I. And then it was 1225 times 3, so it's times square root 3. So this is 35I root 3. We're not done yet, though. You're looking for answers already, right?
Yeah.
Too early. So 7 over 10. 7 over 10. Actually, I'm not going to write it there. I'm going to write it over here because this page is still the wrong way. So we have 7 over 10. So when I get this part right here, the 35 and the 50 are reduced to 7 over 10 again. So it's plus or minus 7I root 3 over 10. And then we also have, from this very first parenthesis, I have to set 5x plus 7 equal to 0. Subtract 5, 7, divide by 5. So my other answer is -7/5. So it's x equals that. So that's why, oh, they didn't reduce it. I would have taken points off the answer. That's not cool.
Okay.
But, so you're going to have that anyways, 35 over 50, and you can tell that's what it is.
Okay.
And then, you know, if you look at this right here and that 35's outside, you can just square it to put it back under the radical. So like you can tell, like if I were doing this problem, I would only do this part
Okay.
because then I know that's that same part right there.
Yeah.
And then I would look here and I'd be like, okay, that's the same. So then I just have to choose, is it negative or positive 7/5? And because I have plus over here, it's got to be the
Negative,
-7/5, right?
Okay.
So a lot of times in math, like do a step of the problem, look at the solutions.
Yeah.
And a lot of times you don't have to finish it, which
Yeah.
makes it easier.
Yeah.
But isn't that just, that's not nice.
Yeah. No.
Okay.
Um.
Charge it up. I'm so surprised there's not more people in here.
I know.
Because of finals, I thought this place would be rocking.
Yeah.
Because it's busier on a regular Sunday than it is right now.
Yeah.
All right, what on that guy?
I don't know. Maybe.
I
you
can
just
look.
go over all of them quickly
Yeah.
on this page.
Sure. All right, let's go here. It's annoying because it rotates.
Yeah, I
the
know. I
wrong
had to
way
do all of
first.
that when I was looking at the key. I had to.
So irritating. All right, so this one. So we look at 11. So this is, we'll say like flashcard moments on here as
Yeah.
well, okay? So this is flashcard moment for sure. So if you have positive x cubed, it starts low and finishes high. So I think of that like down up. It just depends, like the easiest way for you to remember the shape of that. And if it's negative x cubed, it starts up and finishes down. So up, down orientation. And it's a lot easier to think about then as x approaches infinity, y goes to negative, like screw that. It's easier up, down, up, right?
Yeah.
Just to get this. So this one is down, up, right? So it's got to be a positive. So it's got to be positive, odd. So
Okay.
degree is odd, so you can cross off the two even ones.
Yeah.
Leading coefficient is positive, so it's got to be d.
Okay.
Okay?
Yeah.
All right, next one, graphing calculator. You know how to do that? Get the minimum or maximum. Okay, we'll just go over that real quick. I'm gonna put it in,
Oh wait, actually, I think I do.
you go second trace min, second trace max, and you surround the vertex with the cursor.
Wait, where's
Does that ring a bell? So second trace is right there.
Oh, trace.
But you
Oh,
would
yeah.
have it in the y equals, right? And then
Yeah.
you go max or min,
Yeah.
depending whether it's right side up or upside down.
Yeah, I know how to do that.
Okay. This one is positive cubic, so it's going to look like this. Right? So you're going to have two, you're going to have a max here and a min here. Right? So you put the cursor, we'll just do a quick little thing, cursor there and there. That would be, it asks you left bound, right?
Yeah.
And then you got to hit the right arrow to move it over here to the right bound. And then left bound here, right bound here. So after you get right bound, you hit enter twice, and it'll give you these little joyous values.
Yeah.
You know how to adjust your window?
Yeah.
Okay, good. Because this will touch the y-axis at -60. So you can tell right away, you just hit window and make the y less than -60. Okay, so 13. So you can tell what the parentheses are because this crosses at -2, which means it's got to be x plus 2. This crosses at -1/2. So I'm looking at answers, right?
Yeah.
To see if I have -1/2. And don't get the 1/2, right? So if I get x equals -1/2, the parenthesis has to be 2x plus 1 set equal to 0.
Right.
Because I have to -1 divide by 2. That's why I get the -1/2. So it's weird to think about that going to that parenthesis. So that's 2x plus 1. And then +1/2. So that's going to be 2x minus 1. And then it crosses right here at 1.5. So if I have 1.5, that's 3/2, right? Which means that's got to be,
2x minus 3.
yes, 2x minus 3. Squeeze that in there, 2x minus 3. Because I would add 3 first and divide by 2 second.
Okay.
Okay? That's good you get that well, because that's not that easy.
Yeah, and I also
Right?
have it written down here.
Yeah,
But
that
I
always...
just wanted to make sure I knew I was understanding
You were doing
it,
it correctly, yeah. No, that's good though. I'm impressed. Okay, so blah 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 blah. That was way hand drawn curves, curving reading, cube of polynomials. Use a graph. So you know, same thing, right? Because it crosses at -1, it's got to be x plus 1. And then this is where it has a multiplicity of 2 because it bounces off the x-axis, right? So that's got to be x minus 2 squared. And this one's got to be x plus 1,
Okay.
right? Good there. And you know the zeros are what you get from the graph.
Yeah.
And you switch a sign for the parenthesis. Good. All right, 15. Let me flipperoo that page. Rotate. Rotates. Rotate. Okay, so this guy. So descriptor matches f of x, g of x. So f of x is there. So you know what that is, right?
Yeah.
That's pretty easy. Vertical shift.
This one you just enter in your graphing calculator,
Yep.
right? And then you test all the different ones. The same with
Yep.
this one. And then,
Do you remember how to make the prediction?
no.
So I'm just, I'll put it in the calculator on here so you can see it.
Okay.
Stat, edit, and then can you read off? So
Yeah.
are we doing this one or this one? This one, right? Because
Sure.
we want to predict.
Yeah.
So 1,
So-
3, 5, 7, 9.
And then at 1, it's 1.3.
Hold on. 1,
Oh, sorry.
3, 5. You're good. 7, 9. And at 1, it's
1.3.
1.3,
18. And then at 3, it's 18.3.
18.3,
And then at 5, it's 70.5.
70.5,
And at 7, it's 177.1.
177.1,
And then at 9, it's 375.3.
375.3. And which one works the best? We'll just make it go faster. So can you read that? Read that.
0.4x to the third plus
Look how bad that is.
0.8x
Gotta be
squared.
kidding me. Okay. All I needed is x to the third to know
Oh,
which
okay.
regression, so I didn't have to do them all. So we go stat calc cubic, which is number 6. And we're going to go bars, y bars, function, enter. Oops, I didn't want to put it there. I want to put it here. Bars, y bars, enter, enter, enter. Okay, so you got, it's 0.5. That means we put something in wrong. Stat, enter. Look at this list. 1.3, 18.3, 70.5. Let me just try something real quick. Step back. Here, let me do it on this one. Sometimes this one does some weird crap. Stat enter because I double check the points and they're
Yeah.
all correct, so that doesn't make any sense. 13579. Stat edit. And then we have 1.3. 18.3, 70.5, 77.1. 357. Oh, that was it right there. Dyslexic moment. 357.3. That's funny because I looked at it and I saw it backwards again. That's super fun. Stat, calc, 6, store, bars, y bars. Bars, y bars, 1, 2, 3. So now we're good. So when you predict, so we want to know in the year 2006, so you got to subtract 2006 minus 1995, because that's the first year it started, right? So I'm subtracting these two numbers.
Yeah.
I
Get
get
11 years.
So we got to go second table set. I make it equal 11. And then if I go second graph, then I get the value right there.
Oh,
So 630.3.
that's nice.
That's where that comes, right? So
Yeah.
that's a nice little trick.
Yeah.
So second table set to get to where, and you can just plug that number in.
Okay.
Okay?
Yeah.
Handy. All right. Start rotating this one. Anyways. All right, anything else on, so solve by graphing?
Does that mean you just graph, like you put both, like y equals
You
6x and then y
put it
equals
in.
9 plus x squared?
Yes.
And then the
9.
intersection is the
So
solution?
it's negative, you're talking 18, right?
Yeah, or
so-
19, sorry.
Oh, 19. Yes.
Okay.
And this one you get how to do, right? You just plug it in and look where it crosses. And then do you know how to do second trace 0?
Oh, yes, yeah.
You got to surround the x-axis above and below or below and above to
Yeah.
get where it crosses because you need that.
Yeah.
Although you don't need to on that one, right? If I just plug in, I'm just going to plug that one in real quick just
Okay.
because there's a nice little trick on that. It's this one. So y equals, clear that. So we have negative 8x cubed plus minus 13x squared plus 6x. And then we look at the graph, zoom 6. So you could tell it's positive 0.38, right? So you don't have to check that, and you know it's negative 2, 0,
Yeah.
positive. So that makes it easier to choose between the two answers that have the same thing, right? 1 plus 1 minus, and you're good.
Yeah.
Okay. To solve to the 100. So you just get the intersection points doing that, right? I plug this side into y1, that
Oh,
side
yeah.
into y2, second trace number 5.
Yeah.
For number 20, no calculator. How about long division?
That I do not understand.
No
I
idea?
never understood long
Okay.
division.
So
I
we had-
understand synthetic division, but I don't understand long division.
And she said because she put it on here, she's going to give you a long division
Yeah.
one? Okay. So I went over this with Alexis before as well. and I recommend she just listen to the video a couple of times,
Yeah.
right? Because even me going over the way I do it, it's still not that easy, right?
Yeah.
This is number 20, too far. Did I miss a page? 11, 13, 19. I somehow must have deleted a page, but it doesn't matter. I'll just write it here. So we have after. No, I'm being dumb. I just got to go over this side. Okay, never mind. So this thing, I'm just going to add a page because I have to zoom in too much. It gets weird. Let's do this. All right, so we have x minus 2. And you put it in order and you have to have a placeholder, right, if I'm missing x squared. So you say 6x cubed plus 0x squared plus 5x minus 8. So here's what I think about it. So I have two things here, so I always start two things over.
Okay.
So my first answer has to go 2 over,
Okay.
right? And I want to think what up top here times this x equals 6x cubed. And I like writing that off to the side. So what times x, and this x comes from right here,
Yeah.
equals 6x cubed. So that would be 6x squared. So I have 6x squared up here. So the nice part about long division is they're all x squareds going down the line. There'll be x squared, x squared, x squared. It'll be x up here, x here, x here, x here, x here, and numbers going down that way. So when I multiply this, I do 6x squared times x, and I get 6x cubed. I'm always subtracting when I do long division, right?
Okay.
Then I go 6x squared times negative 2, which is negative 12x squared right there. So minus 12x squared. I like to switch it to addition because you guys screw up subtracting all the time. I call it the 3 switches. Switch, switch, switch. And that happens every damn time. Switch, switch, switch. And then all I have to do is whatever the signs tell me to do. It's no big deal, right? That always cancels. That's the whole point of doing long division. You always want the first thing in the next row to cancel. So I just add 12 and 0, I get 12. So I have 12x squared. I bring my 5x down. So plus 5x. Over here I say what? Times x, so that x never changes. Now equals 12x squared. So 12x squared.
So it's 12x.
12x. So plus 12x up here. And again, like I said, right, all the x's are lining up, all the x squareds are lining up. So if stuff gets out of whack, that's your cue. You can tell that it's getting out of whack. So we go 12 times x, 12x squared. So 12x squared. Then I go 12x times negative 2, which is negative 24x right there. That's supposed to be a... Yeah, we're good. Okay, so negative 24 minus 24x. And then we're going to do our 3 switches again. So switch, switch, switch. 24 plus 5 is 29. So 29x. Bring down that negative 8 minus 8. And then over here we're saying what times x equals 29x. So 29. So plus 29. It took me a while to figure out to do this thing over to the side.
Yeah.
It really helps kids understand what you write up here, here, and here, right? So if that helps you, great. If you don't need that, then that's great too, right?
Yeah.
I don't care if you do it or not. So now we go 29 times x, 29x there. So 29x, then we go 29 times negative 2 is negative 58. Parentheses, minus in front. 3 switches. Switch, switch, switch. 58 minus 8 is 50. So we get 50. So that's the remainder right there. So this is a positive 50, so it's plus 50 over this x minus 2.
Yeah. Oh, yeah.
Bam.
Okay. Yep.
That's why you got that in the end.
I was definitely rewatch that a couple times. Because, like, I do, like, I think I understand it.
Right?
Like, I think, like when I was looking at the answer key and doing this, I was trying my best to, like, actually absorb all the different material and stuff. Because,
Yeah.
like, I didn't want to just be copying it down, but I needed to get it in.
Well, when it's that many problems, what are you
Well, I started doing
like
it,
you have
and
no
I was
other
like
choice.
doing it for like an hour and a half, and I was like, I've only gotten through one page, and this is like not gonna happen.
Yeah. You've
And
got
so I was like
8
at dinner with
pages.
my mom, like I was like, how am I gonna get this done? She was like, just like,
Just copy it.
yeah.
Even your
There's
mom
nothing
told
else
you,
can
right?
do.
Right.
So,
And I don't know how you don't realize that as a teacher. Like, you know.
well, actually, I was overhearing when she was stamping stuff off in our class. I was overhearing this one kid saying he spent 7 hours on the entire thing because he couldn't understand it, and he still didn't finish.
Yeah.
And he told that to his boss, and she was like, "Well, that's not gonna. It's gonna be not full credit." What? It's like, what's wrong with you? Like
That
this
is-
kid is like spending so much time on it.
I'd be like, I'm so sorry.
Yeah.
Like, that's not
Well,
cool.
like, I mean, I know this is like middle school or whatever, but my teachers used to be like, if you're spending over an hour on my assignment, just email me. Like, we need
Yeah.
to figure something else out. Which I know is like different sometimes in high school. There's some
No.
stuff that just takes longer, but I also do think that like, if a kid is spending over 2 hours on something.
My goal is a half hour for
Yeah.
homework.
Yeah.
And I try to give kids at least 10 minutes to 15 minutes to work on stuff
Yeah.
in class as well.
Yeah.
Like, I don't want to kill you with it. I just want you to understand it.
Yeah.
right?
Exactly. Yeah.
So one problem of each type is plenty.
Yeah.
Maybe 2, depending on the difficulty, what you need to practice. But
Yeah.
my goodness.
But yeah. Anyways, I understand like the concepts. I just need to like have them re-explained, I guess.
So again, with that, didn't we do the nasty one with 125 and 343? This is
Yeah.
much easier because it's just 8 right there. Cube root of 512 is 8.
Okay.
But you got to do quadratic formula with that.
Okay.
You end up with negative 48 under the square root. You got to break apart,
Okay.
right? And she will still is it all calculator for the final?
This is no graphing calculator, but we still get a scientific.
Okay, so you would have to figure out like that because and I'll say on here, so for number 24, when you get to quadratic formula, you end up with square root of negative 48, and you have to break that apart. So if you only have a scientific calculator, you have to start dividing. 48 divided by 1, 48 divided by 2 is
Yeah.
24, you can't square root 24. 48 divided by 3, you get 16, and you can square root 16, right? So you break that apart to square root of 16, square root of negative 1, square root of 3, so that becomes 4I root 3. And then for that bottom, it would be over 2. So the beginning would be negative 8 over 2, and that reduces to negative 4, and then you would have plus or minus, because 4 divides into 2 twice, so 2I root 3. And then this would be your third answer would be 8, because you said C minus 8 equal to 0, add
Yeah.
8 to both sides. So when I talk to kids about these kinds of problems, if it's x cubed minus 512, this 3 tells me I have to have 3 answers,
Okay.
right? So that's the 1, 2, and that's the third answer.
Yeah.
Okay.
Okay.
So that's your check all the time. So because it's not multiple choice, like you can't look at
Yeah.
answers and try to reduce the amount of work.
Yeah.
You just got to suck it up and do it.
Yeah.
All right. So this one, you got to recognize you can divide 3x cubed out of all of them, right? Which is easy because it's 3 in the beginning,
Yeah.
and then your smallest exponent would be cubed.
Yeah.
That's why you can take it out, and you're good at factoring.
Yeah.
Right? You're good at
I am
factoring,
good
right?
at
Yes,
factoring.
hell yeah, you are.
It's the one
After
thing I'm, like, really
107,
good at.
you're like, damn you. Yeah, I'm good.
I shouldn't have to take that section of the final.
Totally. After a 107, I'd be like, you're good, girl. No problem. All right, so this thing. So these are tricky, right? Let's talk about that one, 27. So 27. So we have x to the fourth minus 34x squared. It's a pain in the neck because you don't have a graphing calculator. Minus 225. That's 252.
I don't like switching between them. Like, it's just like my brain is like gets into graphic calculator.
Yeah, right.
Like, I'm on
that
this
mode,
one
and then you have to go
calculator,
to the
and then I'm like,
regular, and you're
oh.
like, what the hell?
Yeah.
So first thing I would do is try to square root 225.
Okay.
Right?
Yeah, and that's.
And then
Isn't that? I don't know.
it doesn't work.
Oh, does it?
So, but like, I think it ends in 25, so
Oh, 'cause
maybe I'll get lucky.
125 Isn't 125 you can square root 125?
No,
Or you can just square root 25, I guess.
144 to 30. It doesn't matter.
Okay.
So we're gonna do 225. You know you can divide by 5 because it ends
Yeah.
in 5, right? And then I always look at this. I can break that apart, and I
Into
know I can
9.
divide it into 9. So
Yeah.
I'm gonna go 225 divided by 9.
And then.
So even if I have a
Yeah.
scientific calculator, I'm thinking about it like that.
Then you have the
I can
square root
square
of
root
3.
both those, right?
And then you have the square root of 3. Or.
So if we go like this, negative 225 on top and negative 34 on the bottom, those two add to 34, right? 25 and 9. So 25, that's got to be, they're both negative. So then this breaks down to x squared minus 25 and x squared minus 9. And kids say, where did the 34, I wrote the wrong number down there. 34. It was weird, it didn't write it first. So this equals 0. So we set x squared minus 25 equal to 0. So x equals 25, x squared equals 25. And you can square root both sides, so plus or minus 5. Or you could break this into x minus 5, x plus 5, and you get the same plus or minus 5.
Yeah.
But when it's x squared and you can square root that number, I almost always just add the 9 over and square root because it's easier, I think.
Yeah.
So x equals plus or minus 3.
Okay.
So anything else?
I understood this stuff. I
This
think.
good?
Yeah.
Good. And you get like how the, right?
Yeah.
Because it's all to the first power, so it's got to cut through the x-axis and all those.
Yeah.
Okay, good.
This might have been. I had to print this all out myself.
Yeah.
This might have been the one that I accidentally put in, and that's Unit 7.
Oh, yeah, because it says R7 on there.
Yeah.
Do you
So
get
we
how
can-
this depreciation formula, why it's 0.85 right there?
No. Oh wait, is that because you like take? Is this one where you do like 1 minus whatever? Oh yeah, you do 1 minus.
Except it loses 8%, so that's what you said was the answer?
Yeah, unless I copied it down wrong.
Oh, that's why, because it'll lose an additional 15% of its value. So that's why they're doing 1 minus 15.
Yeah.
Okay. I didn't see, that's mean, they put 2 of those in there. So new car will lose 8% the moment she drives it off the lot. At the end of the year, after each year, it'll lose an additional 15% of its value. Yeah, so that one. So it started at, oh, so they did the 8% first. Because if we do 33,575 times, so for the 8%, I'm gonna multiply it by 0.92 because I'm doing 1 minus 8%, right? Which is 92%. And that's where that number came from.
Okay.
So it's a 2-step problem on that one. That's
Yeah.
mean. That was number 8. So I'm just gonna write that down because that's not nice. So we started with 33.75, and then we're going to multiply that times 0.92 because it lost 8% value. And that equals 30,889. And then every time after that, it loses 15%. So 1 minus 0.15 equals 0.85. So we're going to start with the 3,889. It's actually a good problem, even though it's mean, because it's true to life.
Yeah.
And then it's just 1 year after that, or you're just writing the equation. So I can't tell if that's an X. We'll assume it's an X. Okay, this looks just super fun.
That one you just enter all in your calculator
Yeah,
and
the
then
whole
test all
damn
the
thing.
different ones, right?
So you graphing calculator, you
Yeah.
have to. Yep, test all the different ones exactly.
then-
And you can look at the values, right? Because they're increasing.
Yeah.
It's not like a constant rate they're increasing. So it's going up ever so slowly, exponentially. Interesting. So solve, do you get the whole, we're trying to get a common base there.
Yeah.
So
The bases.
that's
I do
2
get
to the
that.
third, that's 2 to the fifth.
Yeah.
That's 4 squared and 4 to the third. Okay. You're just plugging crap in there, right? So that's
Yeah.
no big deal. You have to subtract 2020 minus 2005 to get that 15. What is your grade in there right now? You got a shot. What do you have a shot at?
I think just keeping my beat. Unless
What is it, 80?
85, 84.
Oh,
It went
that's
up a
beautiful.
lot. I know.
Thank God. Like, I don't know if your parents have told you they're proud of you for the work you put into this
Yeah.
class, especially given your feelings about the class. Like, it is so, like, seriously, it's impressive because
Thank you.
not many kids can do that, right?
Yeah,
Because
thank
eventually you just get so mad you can't function anymore. And maybe you were like that, and then starting tutoring helped kind of bridge the gap a little bit, so
Yeah.
you like had some more positivity
I have
about
an
it.
84.7.
And if do you know
It's 20% of my grade.
the schedule, you know the Mohai schedule, how you do that? Do you have the Mohai
Oh
schedule
yeah,
app?
and then you can go to the calculator.
Graduation hat. So what'd you say? 80
I have
straight.
an
She doesn't round, and you want to keep your B.
4.7.
And then
It's
current
worth
grade
20%.
is 84.7. 20%. So that means you can get a 61 on the final and keep
Keep
your
an
B.
80. Yeah.
Okay, 62 because you won't round.
Right.
You get a 61.2 and she'll be like, no.
Okay.
Like 79.99, no rounding.
Okay.
That's amazing.
Yeah.
Thank God you got, at least it's not like massively stressful,
I
right?
was so scared because before I took that test that I did good on,
Oh, yeah.
I was at an 80, I think. Like,
And then the last one you took, you
got
thought
an
you didn't
80s.
do as well, right?
No, and then I got
And
an
you ended up
86.
doing better. That's awesome too.
yeah, that was good. But this test, I'm a little, like, this final is weird because she was like, I don't want you guys to write your own note card, but I'm giving you a note card. And then she showed it to us, and I was like, that's going to confuse me more than
Yeah.
anything. Like,
Then
I
you're
don't-
writing your own note card.
Yeah, like, I was just like, this is like,
Like I'll give, like in pre-calc, I'll give formula sheets for some tests.
yeah.
And like I'll have 2 formula sheets to choose before, and I choose the one with more information because it's better.
Yeah.
And it's easier to understand. So like I'll give that on the final because they've already used it.
Yeah.
You know, like I might have given a unit circle on the final because there's formulas on the back, and at least you have the unit circle, so you don't have to think about all this stuff on the unit circle.
Yeah.
Do you know if she's giving you a unit? Oh, she
Yeah,
didn't?
we are getting
Oh, good,
those.
good. Good. All right, so good on that. This thing, just graphing it, right? Are you good on all those?
Yeah, so much.
Shaky?
Yeah.
So you remember E's 2.7?
Oh, right.
So it's 2.7 to the x. So E equals 2.71828, but 2.7 is fine.
Yeah.
So that's exponential. Any number to the x power goes like whoosh, up super fast. It's over doubling. So you could think of it like that, right? And then it's up 2 because that's the horizontal asymptote, right? Because it moved the whole function up 2. Whereas normally it would go along the x-axis and then go up super fast. Because the plus 2, it just goes up 2.
Yeah.
Okay. And then this one, so that's going super fast, right?
Yeah.
And so it went up 1, and this makes it go left 2 because of the plus 2,
Yeah.
right? So, and she didn't show you any order pairs on there, right? So because this is, will this be no calculator or calculator?
It says no graphic calculator.
Starting here and all the
I
way?
guess so, yeah.
And then that's what her key looked like. She did that little, okay. Because sometimes, like, I'm doing advanced at the same time, and they make them get like 3 order pairs along that.
Oh.
So I have all these strategies to do that.
Yeah,
but if she
no.
just showed it
She just did that.
generally like
Yeah.
that, you're good. Who cares? You just have to know the general shape of an exponential goes up super fast.
Okay.
And then you move it left, right, up, and down, and call it good.
Okay.
Okay?
So that was 7.
That was 7.
This one I actually Oh wait, no, I still copied this one. Sorry.
Yep. So all we're doing is adding the 2 functions, combine like terms. Then we're just subtracting. You got to remember to distribute the negative into the
Yeah.
parenthesis, right? Multiplying, you can FOIL or do the box, either one. Dividing, you always have to take the bottom equal to 0, right? Because it can't be 2, because
Yeah.
2 minus 2 would be 0, so accept 2. So literally, I would look at that and just set it equal to 0, and then I know that's the answer.
Yeah.
That always factors, right?
Yeah.
So that cancels out, so it's just 3. So that's what the function is. This one, these are trickier.
I understand these though.
You do? Good.
Yeah.
See, you get the hard stuff.
Because then, like, if you like the way I think about it is that like if you have this, then this goes into that.
Yep.
So I just think of that.
Do you ever, yeah, no, you get it. I'm not going to mess with your head. I'll keep my mouth closed. So, f of f inverse of 5.
Oh.
So you said x minus 9, and then the inverse of x minus 9.
It's plus 9.
Yep.
So it's 0.
So it's just x, and then if you plug 5 into x, it's just 5.
Okay.
Okay. So this one squared of x, find the inverse. So we're just switching x and y and solving for y. Are you good doing that? Or you want to see that?
Yeah.
So
Can you
module
show that?
6, number 7.
Yeah.
So mod 6, number 7. So we have f of x equals 8 minus 2x in parentheses squared. So this is really y, right? So we're going to switch x and y.
All right.
8 minus 2y squared. And we have to solve for y. So first step I got to do, I got to square root. Right? And then anytime you square root, you got to have that plus and minus in front. Right? That makes it nastier. Because why wouldn't it? So plus or minus square root x equals, and the square root makes the square go away. So we get 8 minus 2y. It's no big deal that it's plus or minus, because that just makes it look like quadratic formula, right? And you can deal with plus or minus, like who cares? So getting the y by itself, first thing I got to do is subtract 8 from both sides. And then I'm going to write that like negative 8 plus or minus, right? To make it look like quadratic, and then it doesn't freak you out as much. So negative 2y, divide both sides by negative 2. And I show it on all the parts, right? Because that's positive 4 right there.
Yeah.
So 4 plus or minus. So if I have plus or minus, the weird thing is this negative doesn't matter. Because if I have a
'cause it's
negative
plus or
times a
minus
net,
anyways,
right?
yeah.
So it doesn't matter. It's going to be plus or
Yeah.
minus still, right? So just square root of x over 2. No big deal,
Okay.
right? And then, so they wrote it like that. Like I would take points off that. So actually, I won't show it like that. Because that's why I showed 2 fractions, because that
Yeah.
reduces, right? So they didn't do it right. Like
Yeah.
I take a half point off because they didn't finish it. So you should just have negative 8 negative 8 plus or minus square root of x over negative 2. And that's why it canceled and it was just positive there. So they just canceled those two negatives,
Okay.
right? Because it didn't matter anyways.
Right.
But that's why I like the two fractions. It makes more sense.
Yeah.
To me, anyways. All right. Do you know how to? You remember? Oh God, this is so long ago. That's insane.
I do
Or
remember
first
that.
of all, you remember this, right?
Yeah.
Cube root of 8 squared.
Yeah.
And then you have to say what it is. So cube root of 8 is 2. 2 squared is 4. Oh, that's fifth. 5 on top. I can't tell. That's why it's 32 there. This one, you divide 4th root 81 is 3.
Yeah.
And then you go 20 divided by 4 to get the 5.
And then if you have an absolute or if you have an odd number in the exponent, then it's
Absolute value. Perfect. Look at you go. 7 times 6. I mean, you have learned a lot this year,
Yeah,
despite
I
your
have.
love of math.
I
you
hope
have
that
learned a
something
ton.
transfers over to AP Stats.
Yeah, some part of it will help you,
Please,
right?
factoring,
Like, please
maybe?
God. So 7 plus 8 is 15. That's why it's x to the 15th. So when the number in that's called the index, that little number right there, when those are the same, you can make a jumbo cube root or whatever the hell that number is. I can't tell. It looks like cube root. And then you can do 270 divided by 5.
Oh, yeah.
That's where your 54 came from. And
Yeah.
just subtract the exponents.
Yeah.
20 minus 1 is 19. Yeah.
Yeah.
Good. All right. God, I
It
can't
got
believe
all
how long
stormy
ago that
outside.
sounds like. Yeah, it's been weird weather of late. Oh God, it looks like hell right there.
Oh my gosh.
It's
My
like-
dog, every time there's a thunderstorm,
Does-
she hides underneath my bed
Really?
and cries.
And she's like shaking and
I
everything.
have and if I'm there, she will just be like on top of me,
Yep.
like shaking, and so I can't like. I have a golden retriever.
Yeah.
Did I show you a picture of her?
No,
she's
the
so
gold-
cute.
I know golden retrievers are super cute.
She's the best. Her name is Sunny, and oh my god, my friend stole my phone. Wow, that's nice. Oh, yeah, this is Sunny.
Aw,
Yeah, she's very cute.
I
But
like how she's older, huh?
She's 9, yeah.
9, yeah.
This was her on her birthday. We got her like a little
Oh, very cute.
birthday thing. But anyways, she's like,
And she would wear it.
yeah,
Like, you
for
kept
like
it?
a little bit.
Yeah.
But she just like, I can't like, I don't know. I feel like this is with all the golden retrievers, but like when you stop petting them, they just kind of like slap you.
My dogs do that
yeah.
too.
So I don't
It's
know.
like more pets, more pets.
Yeah.
Yeah.
And she just like freaks out. But then if I'm not there, she just hides underneath.
Do you have a weighted blanket?
I do, yeah.
You can
I
try a
don't-
weighted blanket on top of her.
Maybe we used to have when she was younger. Like she's a little bit better now, but when she was younger, we had this like it wasn't exactly a weighted blanket, but you like put it on them. It was like kind of cold.
Oh, yeah, yeah, yeah.
And it kind of did the same thing, and that kind
Soothing
of
kind of
She
vibe.
used to be really scared of the garbage truck.
Oh God.
Yeah.
Because it makes a big banging noise and
Yeah.
everything. Yeah. It's funny.
Yeah.
The little Aussie I have, like I could go like that, and
Yeah.
does that like oh,
I know.
and then I make
So
fun of
funny.
him. I'm like, oh, did you get scared?
Yeah. She would be a great therapy
Hilarious.
dog if she didn't have anxiety too.
Yes, right,
She
right.
just feeds off of everyone else's anxiety.
Okay, so no big deal, right?
Yeah. Wait, let me just make sure my parents.
Yeah, 303. When do you get to drive?
I'm trying to get my license by July.
Okay.
I like really I'm getting a lot more confident now. For
Yep.
a really long time I like hated driving.
You're getting super
I
scared.
find it I don't know. I mean, I'm getting more confident now.